Hello students, let us solve a problem on design of shaft, Module 3. A line shaft is to transmit 30 kW at 160 rpm. It is driven by a motor placed directly under it by means of a belt running on a 1 meter diameter pulley keyed to the end of the shaft. The tension on the tight side of the belt is 2.5 times that on the slack side, and center of the pulley overhangs 150 mm beyond the center line of the end bearing. Determine the diameter of the shaft if the allowable shear stress is 60 Newton per mm square and weight of the pulley 1600 Newton. So in this shaft problem, we are having a shaft which you have to design, and there may be a gear, pulley, but in the question they have given pulley. So since they have given pulley in the question, you should have a knowledge of pulley. A pulley will have a belt connected to the other end. It can be up or downwards. They are not mentioned in this case, but the belt will have a tight side and a slack side. The pulling side will be tight and the slack side will be loose side. And they have given the tension on the tight side is 2.5 times that on the slack side. And they have given the pulley overhangs 150 mm beyond the center line of end bearing. That means from the bearing one there to other bearing, it is having 150 mm gap. Then other data are given. Weight of the pulley is given, etc. So we'll write the given data. Given power 30 kilowatt, RPM N is 160, and diameter of the pulley is given as 1 meter. So we'll convert into 1000 mm. And we'll write the radius because we need for the calculation. And tension on the tight side and the slack side, we say tight side as T1 and slack side as T2. So T1 by T2 is 2.5. Shear stress is given, the pulley is given. So we'll solve this problem. First, when you're solving a design of shaft problem, first you have to look whether torque equation is given, whether they have given data for the torque. Torque is based on the power. Sometimes the data will be unknown. So in this case they have given the power and RPM. So directly you can calculate the torque by the general equation. Torque equals 9.55 into 10 raised to 6 P by N. You can find in equation 3.1 in data and book Balvi Reddy and Mahadevan. Substituting power and RPM of 30, remember power is in kilowatt, so you should only substitute 30, not 30 into 1000. So rest of the parameter is taken care by the equation itself. So you get the answer 1790625 Newton mm. So this is one side of the torque. We'll keep it like that. For the belt, I have told there is a belt and gear in the pulley which will be attached to the shaft. So since it is a belt attached belt drive, we are having a pulley attached to the shaft. The following equation we have for the belt drive is a alternate equation for the torque. Torque T, or in some book they refer it as M suffix T, equals nothing but T1 minus T2 into radius of the pulley. So if you have a pulley of a given diameter, what are the tension ratio? Tension on the tight side and tension on the slack side. Difference into radius gives you torque or a couple. That is a force acting on the force required to rotate the pulley. So substituting the given data, we get T1 minus T2. But do you know the difference between T1 by T2 is 2.5? And you substitute that, we get T1 equals 2.5 T2. We substitute in the previous equation and simplify it. You get T1 as 5968.75 Newton and T2 as 2387.5 Newton. So this is calculation for belt. Remember, whenever we are having a belt drive, so you have to use this equation. Torque equals T1 minus T2, difference in the tension into radius. That will give you torque. And general equation for the torque, you know. So using that you get the answer. This is only for the torque. Now in this question the load is acting downwards because they told the weight of the pulley. Weight of the pulley is only mentioned. They are not mentioned about other data, but weight of the pulley is always downwards. And we are going to imagine that the pulley is going to transfer the load to the bottom because they are given in the top in the equation. it is driven by a motor placed directly under it. So something below is rotating it. So because of the belt connected to the motor here below, it will pull the entire pulley downwards. So what is the stress acting on the shaft because of the pulley acting downwards? So total, first we will find what is total downward force. Now total downward force can be tension T1, tension T2 and weight of the pulley. Obviously weight will be always downwards. So substituting it and writing the arrow as downward direction, we get total load as 9956.25 Newton. This is total downward load. There is no horizontal load because there is only one pulley and our load are acting downwards. So continuing the problem, we have to solve for bending moment diagram to find the maximum bending. So we got the torque we got it, and we have to find bending. Then we have a general equation for torque and bending together to find the diameter of the shaft. So how we will draw a bending force diagram, taking a moment at B. So if you take it a moment at B, bending moment at point B is equal to 0, because at point B, load into distance of the load from the B. If you consider the point B, entire load that we have calculated in the previous equation, you can see in the previous equation 9956, that was the load. So load 9956 into distance of that load from the B is 0. So you get bending moment equation of 0 in the first portion. Second portion, A. So A will be the same load into 180 distance. So entire load into the distance will give bending moment at A from B. So distance taking moment of B means you are measuring every load from the point B. Why it is negative? So as per sign convention, downward force is always considered as negative. So downward force is always considered as negative. So we will consider minus. So we will get minus 1490. And we are going to draw in a diagram. If you draw a straight line, 0 and 194. So that will be the maximum load because there is no other bending moment. Now in the diagram, if you like maximum, it can be positive or negative. Maximum negative will be here. If you neglect this sign, maximum here. So here diameter of the shaft will be due to combined bending and torsion load according to maximum shear stress theory. So if you go to data handbook, you have a formula. Diameter of the shaft is a combined relation. This is a general formula, equation 3.6b, where M is the moment, maximum moment, T is the maximum tension. So M is the maximum moment, T is the maximum tension, Cm and Ct are the constant which are going to define later. Sigma max is given in the question. And the second part of the equation, 1 by k minus 1 minus k to the power of 4 is considered for a hollow shaft. If there is a hollow shaft, then you have to find the outer and inner diameter ratio, that is k parameter. But in this case, there is no hollow shaft, it is a solid shaft, so the k is 0. Then these are the given data. If they don't give in the question, you can assume minor shocks Cm equals 1.75 and Ct equals 1.25. K for a solid shaft is 0. If you go to data handbook, design of shaft, you can get this parameter. You are going to assume minor shocks. Substituting the all the datas, you get D equals 71 mm standard diameter from that, and then you have to measure. This is the data which you got from the equation. From the data book, you have to go and find the diameter value. D equals 71 mm is the answer. You get you will get somewhere 70 point something, and from that handbook the next available value is 71. Thank you.